Explorer-1, NASA's farthest-traveling spacecraft, continues its extraordinary journey through space, transmitting invaluable data from the deepest regions of the universe for nearly 50 years. This remarkable probe has revolutionized our understanding of space. Recently, however, it has begun sending disturbing signals back to Earth, leaving the entire space community in shock. Are these unsettling transmissions the result of a technical malfunction, or could they be linked to extraterrestrial activity? Join us as we uncover the truth behind these alarming messages. Since the dawn of time, scientists have been captivated by the mysteries that lie beyond our planet. This curiosity led to the groundbreaking launches of Explorer-1 and Explorer-2, among other ambitious space missions. The journey began with the launch of Explorer-2 from NASA's Kennedy Space Center on August 20, 1977, followed 2 weeks later by Explorer-1 on September 5, 1977. These twin spacecraft, each weighing about 720 kilograms, roughly the size of a small car, were sent into space on a path toward the outer planets. Throughout their thrilling odyssey, these brave explorers traveled in various directions and at varying speeds. A significant moment occurred on December 15, 1977, when Explorer-1 surpassed its twin due to differences in their trajectories. Since then, Explorer-1 has become an invaluable asset, providing a wealth of data and unraveling space-related mysteries. Before delving into the unsettling new findings from Explorer-1 that have stunned the space community, let's take a look at some of the awe-inspiring images captured by the spacecraft during its Jovian imaging mission in 1978. Positioned approximately 265 million kilometers from Earth, Explorer-1 sent back an astounding array of images. In January 1979, it embarked on an extraordinary 100-hour mission to capture a captivating time-lapse film showcasing 10 rotations of Jupiter. The resulting 3,750 images allowed us to witness Jupiter's magnificent dance in exquisite detail. In the months that followed, Explorer-1 ventured through Jupiter's moon system and made a remarkable discovery: a small ring orbiting the planet, as well as 2 previously unknown moons, Thebe and Métis, further expanding our understanding of Jupiter's fascinating domain. To ensure a safe passage and avoid a potential collision with Titan, one of Saturn's moons, corrective maneuvers were carried out. Explorer-1 continued its heavenly journey around Saturn, uncovering 4 additional moons: Mimas, Enceladus, Tethys, and Dione. With the completion of its Saturn mission, scientists decided to push Explorer-1 and Explorer-2 beyond the boundaries of our solar system. Traveling through space at an astonishing rate of 325 million miles per year, a new chapter began in January 1990 with the start of the Explorer interstellar mission. During this phase, Explorer-1 captured some of the most iconic photos in history, immortalizing the Sun and most of the planets. A key figure in extending the mission beyond its original goals was renowned space scientist Carl Sagan. As part of the Explorer missions team, Sagan passionately advocated for capturing one final set of images as a gift to humanity. Against all odds, his perseverance paid off on February 14, 1990, when Explorer-1, now 6 billion kilometers from the Sun, embarked on its famous family portrait of the solar system. These stunning images, totaling 60 in number, became a cherished addition to the spacecraft's impressive collection of 67,000 photos. During its encounter with Neptune, Explorer-2 achieved a remarkable feat. It recorded wind speeds exceeding 1,000 miles per hour, setting the record for the fastest winds ever recorded in our solar system. As the spacecraft passed within 280 miles of Neptune's atmosphere, rich in methane, it provided invaluable insights into this distant planet. Notably, Neptune's largest moon, Triton, was revealed to be one of the coldest places in our solar neighborhood, with surface temperatures plummeting to a bone-chilling -391 degrees Fahrenheit. Triton's unusual features, such as nitrogen gas-emitting ice volcanoes that launched frozen particles 5 miles into its mysterious atmosphere, further captivated scientists' imaginations. These extraordinary discoveries deepened our understanding of the vast variety and complexity of celestial bodies in the farthest reaches of our solar system. But the story doesn't end there. Recently, Explorer-1 made one of its most astonishing discoveries to date, shocking the entire space industry. Let's take a moment to reflect on the incredible accomplishments of the spacecraft over the past 45 years. The achievements of the Twin Explorer spacecraft have been nothing short of groundbreaking. More than 4 decades ago, their early observations of Jupiter and Saturn's moons left scientists in awe and shattered previous assumptions about these distant worlds. These moons, once thought to be inert and heavily cratered like our own moon, were found to be teeming with geological activity. Explorer 2, in particular, achieved several historic milestones during its journey. In 1986, it became the first spacecraft to fly by Uranus, and just 3 years later, it performed another remarkable feat by flying by Neptune. To this day, it remains the only spacecraft to have undertaken such a journey. As the Explorer spacecraft continued their odyssey, NASA implemented various measures to extend their operational lifespan. Non-essential components and heaters were deactivated to conserve energy, ensuring that these brave explorers could continue their mission well into the next decade. The estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this remarkable endeavor from the very beginning, the culmination of the Explorer missions is both a moment of pride and a behind the Explorer missions have far exceeded their original expectations, with a vast amount of data provided by these spacecraft yielding critical insights, sparking numerous scientific breakthroughs, and fueling the imaginations of countless researchers and space enthusiasts. Explorer 1 and Explorer 2 were far from ordinary spacecraft. They were carefully designed as stable platforms, rotating at a rate 15 times slower than the hour hand of a clock. This unique design minimized visual blurring while the spacecraft captured images and data as they sped through the vastness of space. Even before reaching the outer planets, the spacecraft's imaging capabilities began to astonish both scientists and the public. The spacecraft transmitted images of Jupiter long before reaching the gas giant, showcasing its swirling clouds and the iconic Great Red Spot. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly captured attention. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected unusual signs from Io, later confirmed by dramatic images of towering volcanic plumes and a surface scarred by volcanic material. One of Io's most prominent volcanoes, Pele, erupted with a force hundreds of times greater than Mount Everest's height, covering an area almost the size of France. Although the spacecraft's cameras were eventually shut down to conserve power and memory before their journey into interstellar space, it's important to note that they did not capture images of Mercury or Mars, for various reasons. Alongside the Explorer missions, NASA has launched other notable spacecraft like Pioneer 10, Pioneer 11, and New Horizons. Explorer 1 passed Pioneer 10 on February 17, 1998, marking the moment when Pioneer 10 became the most distant spacecraft. Explorer 1 continued its solitary mission for another 14 years before finally entering interstellar space on August 25, 2012. NASA did not officially announce this achievement until 2013. One particularly remarkable aspect of the Explorer missions was the use of gravity assist maneuvers. These maneuvers played a crucial role in propelling Explorer 1 and Explorer 2 on their ambitious journeys to explore the outer reaches of our solar system. Instead of relying solely on their own propulsion systems, the spacecraft performed gravitational dances with some of our solar system's most massive planets. This complex strategy allowed the spacecraft to harness the immense gravitational pull of these planets to slingshot themselves on their way, conserving fuel and gaining the speed needed to visit distant destinations. Executing a gravity assist maneuver requires precise calculations, and any misstep in timing or trajectory could have caused a disastrous deviation. The flight teams meticulously planned the spacecraft's paths, factoring in the gravitational effects of each planet they would encounter. After years of careful planning and precise computation, the gravity assist maneuvers were executed flawlessly. This strategy was a triumph of engineering ingenuity. Explorer 1 and Explorer 2 benefited from the gravitational pull of 4 planets during their grand tour of the solar system. Their first gravity assist occurred during their encounter with Jupiter, followed by a visit to Saturn, famous for its majestic rings and intriguing moons. Explorer 1 also performed an additional gravity assist as it passed Titan, Saturn's largest moon, before embarking on a thrilling journey to Uranus and its 27 moons, and finally, a captivating flyby of Neptune, a planet known for its striking blue hues. After launching from Earth, Explorer 1 and Explorer 2 embarked on their ambitious mission to explore the outer planets, relying on several key strategies and technological advancements. First, the trajectory of both spacecraft was meticulously planned to optimize their encounters with various planets. This involved precise calculations of when and where to perform gravity assist maneuvers to achieve the desired paths. Gravity assists, as mentioned, played a vital role in the missions, enabling the spacecraft to gain speed and alter their trajectories by flying close to massive planets like Jupiter and Saturn. The spacecraft's longevity and redundancy were also crucial to their success. Both Explorer spacecraft were designed with durability and redundancy in mind, equipped with backup systems to ensure continued operation even if some components failed. This robust design allowed them to operate far beyond their original mission lifetimes. In terms of data storage and transmission, the Explorer spacecraft were equipped with advanced systems to store scientific data and send it back to Earth. While the transmission rates were slower than modern standards, they were sufficient to relay valuable information about the outer planets and beyond. The spacecraft carried a suite of scientific instruments, including cameras for imaging, spectrometers for analyzing composition, magnetometers for measuring magnetic fields, and plasma detectors for studying charged particles. Throughout their missions, the spacecraft relied on precise navigation systems to maintain their course. Small adjustments were regularly made to ensure the spacecraft stayed on track for their planned planetary encounters. Additionally, NASA's Deep Space Network, DSN, played an essential role in maintaining communication with Explorer 1 and Explorer 2. This global network of ground-based antennas allowed for consistent communication with the spacecraft, even when they were far from Earth. After completing their primary mission to study the outer planets, Explorer 1 and Explorer 2 embarked on their interstellar mission, venturing into deep space beyond the reach of the Sun's magnetic field. This phase involved optimizing power usage, shutting down non-essential systems, and preparing for long-term data transmission back to Earth. The combination of these strategies and technological innovations enabled Explorer 1 and Explorer 2 to achieve unprecedented success in exploring the outer solar system and beyond. Their discoveries have revolutionized our understanding of planetary science, astronomy, and the nature of interstellar space. As these esteemed spacecraft continue their journey into the unknown, they stand as a testament to human ingenuity, perseverance, and our boundless curiosity about the universe.